Hello ladies and gentlemen, welcome to section 5.6, parallel and perpendicular lines. What you're going to want to have on you is your notes, a pen or pencil, and also a calculator today. So this video is going to focus on how to determine whether lines are parallel, perpendicular, or neither, and then we're also going to learn how to write equations of parallel lines and perpendicular lines. So today is going to be a lot more algebra today. But first, we need some vocabulary. So, parallel lines. Parallel lines are lines that do not intersect. So they look something like that to one another. Now, something that's really special about them, and we're going to use a lot today, is that they have the same exact slope. So both of their slopes are going to be 1/2 and 1/2, or 2 and 2. They have to be the same slope for the two lines to be parallel. Now, perpendicular lines. You guys have heard of perpendicular, possibly. Perpendicular means that these lines cross at a 90-degree angle. So they're going to look something like this. They're going to cross a perfect 90-degree angle, and they're going to put little squares in there saying they're 90 degrees. That means that they are perpendicular to one another. Now, their slopes, they have what's known as opposite reciprocal slopes. Now, I'm going to explain what opposite reciprocal means in a moment. We're going to want to make sure that we find that they are opposite reciprocal. Now, opposite. We know opposite to mean the other thing, right? So, basically what opposite means is you're going to change the sign of the slope. Basically, if it's a positive slope, we're going to make it a negative slope. If it's a negative slope, we're going to make it a positive slope. Now, if you remember when we talked about reciprocals, we talked about that when we were dividing fractions. Reciprocals means you're going to flip the fraction around. So, if it's a 1/2, the reciprocal of him is 2/1. Notice how I just flipped it around. So an opposite reciprocal, if we would have an example of this, if we would have 1/3 as one of our slopes, an opposite reciprocal of that would be -3/1. So 1/3, its opposite reciprocal is -3/1. That's going to be very important when we're looking for perpendicular lines. So let's take a look at our very first example here. You're going to want to write an equation of a parallel line. So they have a line that passes through 12,5 and is parallel to the graph y = 2/3 x - 1. So what we're going to want to do is first figure out what kind of slope is my new line going to have. So they want to know a line that passes through this point and is parallel. So if I remember, if I go back to my little vocab here, if I have parallel lines, I have the same slope. So I'm going to look at the equation of the line they gave us, and I'm going to figure out what's the slope. Well, we know from our previous work, slope is what's ever in front of x. So 2/3 is my slope. So that is going to be my new slope of my new line. Now, I have slope and I have a point. Now it becomes exactly what we were just doing. So we're going to use point-slope form since I have a point and a slope. So I have y minus y1 equals mx minus x1. This should kind of be remembering. You should be able to remember this just a little bit before Christmas break. So my x and my y, these are my x1 and my y1 right here. So let's pop that into the formula. Y minus y1, and I know y1 is 5. Slope is 2/3 x minus x1, 12. Cool. Now, what I need to do is get it to y equals stuff. So let's distribute this 2/3 in here. So I'm going to have y minus 5 equals 2/3 x. Now, 2/3 of 12. That's kind of hard to think. But I know 1/3 of 12 is 4. So 2/3 must be 8. You can also do that on your calculator. It should give you a perfect 8 on your calculator. Now I need to get y alone, so I'm going to add 5. And I get y equals 2/3 x minus 3 for my equation. Notice how my slope is the same, but my y-intercept is different. That's always going to happen on parallel lines. You're going to have same slope but different y-intercepts. Let's try the same one here. So a line passes through -3, -1, and it is parallel to the graph of y equals 2x plus 3. So, just like we did last time, I have a point, and I need to be parallel. So parallel means same slope. Just put a little note here. Same slope. So what I'm going to do is I'm going to take the same slope, the slope right here, and make that my new slope. And I have the point of -3, -1. So just like last time, we're going to use point slope form. So I'm going to go y minus y1 equals x minus x1. So this is my x1 right here. This is my y1 right there. So my y1, I said, was -1. Slope was 2, x minus my x1, which is -3. Be very, very careful with this double negative. I noticed a lot of you forgot about that on the last quiz we did. So be very, very careful with these double negatives, because that's going to actually give me y plus 1 on that equation. Distribute this 2 in. I'm going to get 2x. This would have became a positive 3 because I have two negatives right beside each other. So I'm going to get plus 6, 2x plus 6. Subtract my 1 over here. I'm going to get y equals 2x plus 5. That is my final answer. Notice how it's same slope, different y-intercept, because they are parallel. Let's take a look at this problem. This one, they just want to classify. They're going to give me two lines. They're going to say, hey, are these parallel? Are these perpendicular? Or are these neither? Best way to do this, get both of them to be y equals. So this one I notice is y equals right away, so I don't have to worry about it. But this one, I need y alone. So we're going to write that one down here. Let's get that y alone. So, divide by 4. -5 over 4x plus 12 divided by 4, 3. So here I have my two lines. Just going to rewrite this one down there. So now I need to look at these slopes. Are they the same to be parallel? No, they are not the same slope. Okay. Perpendicular. Remember, perpendicular meant opposite reciprocals. So are the opposite signs of one another. So this one's negative and this one's positive. So that checks out. They're opposite signs. Now perpendicular also meant they had to be reciprocals of one another. So 4/5, its reciprocal would be 5/4. So I have an opposite reciprocal. So I know I have perpendicular lines, because negative 5/4 is an opposite reciprocal of 4/5. Last one, writing an equation of a perpendicular line. So this one, they gave us a line that passes through 2, 4. I need to be perpendicular to the line y equals 1/3 x minus 1. So unlike last time when it was parallel, I can't just steal the slope. So my slope was 1/3. I can't just steal that 1/3 and go on. I actually need to find its opposite reciprocal. So opposite reciprocal of him. Opposite would be negative, because he was positive before. And reciprocal, I need to flip it. So instead of being 1/3, I'm going to be 3/1. So my new slope, the slope I'm going to use, is -3/1, or just simply -3. And they gave me my point of 2, 4. So I'm going to use point slope form again. Like that. And let's plug in. So this is x1, this is y1, so my y1 is 4. I found m to be -3. X minus x1, which is 2. So I can have y minus 4 equals -3x. -3 times -2 is a +6. All I did there is distributive property. And let's add 4. Get y alone here. Y equals -3x plus 10. Notice how both the slope and the y-intercept are different on this one, because they are perpendicular. Your slope will always be opposite reciprocal of what you were given previously. So always watch out for that. Make sure you know what they're asking for before you even start the problem. Alright? And that is the end of the first video. See you later, Sabers.